The 4-hour fire rating requirement for separation walls between different occupancies in a building is specified in the International Building Code, commonly referred to as the IBC, and not the National Electrical Code, abbreviated NEC. The IBC is a model code developed by the International Code Council, abbreviated ICC, and is widely adopted by jurisdictions in the United States. Specifically, Section 508.1 of the IBC states that fire resistance rated walls shall be constructed in accordance with Section 721.2 to provide a minimum fire resistance rating of 2 hours for buildings of type Roman III and Roman IV construction, and a minimum fire resistance rating of 4 hours for buildings of type I and Roman II construction. The two types of construction mentioned in this section refer to the building structural type, as defined in Section 602 of the IBC. Type I and Roman II construction are typically used for buildings with a higher risk of fire, such as high-rise buildings, hospitals, and schools. Type Roman III and Roman IV construction are typically used for less risky buildings, such as single-family homes, offices, and retail stores. The 4-hour fire rating requirement for separation walls between different occupancies is intended to prevent the spread of fire from one occupancy to another in the event of a fire. A 4-hour fire rating means that the wall must be able to withstand a fire for at least 4 hours before collapsing or allowing fire to spread through it. Now let us talk about construction types. Firstly, Type I construction is the most fire-resistive construction type. This typically involves non-combustible materials such as concrete and steel, offering maximum protection against fire spread and structural collapse. High-rise buildings and structures housing critical infrastructure often utilize Type I construction. Secondly, Type Roman II construction also relies on non-combustible materials, similar to Type I, but may have less stringent fire resistance requirements. It is commonly used for buildings where fire resistance is essential, but the potential fire load or occupancy type doesn't necessitate the highest level of protection. Thirdly, Type Roman III construction allows for the use of combustible materials in exterior walls, albeit with specific limitations in fire retardant treatments. Interior elements may be constructed from wood or other combustible materials, provided they meet fire resistance standards. This type of construction is frequently employed in commercial buildings and multi-family dwellings. Fourthly, Type Roman IV construction, often referred to as heavy timber construction, utilizes large dimension wood members for structural support. These heavy timbers exhibit inherent fire resistance due to their slow burn rate and ability to maintain structural integrity for an extended period. Type Roman IV construction is commonly found in historic buildings, warehouses, and certain commercial structures. Fifthly, Type V construction is the least fire-resistive construction type, permitting the use of combustible materials for both exterior and interior elements. This type of construction is typically used for single-family homes, small residential buildings, and structures where fire resistance is not a primary concern. Now let us talk about the International Building Code, or IC, in more detail. The IBC is a comprehensive model code that establishes minimum requirements for building design and construction. It addresses various aspects of building safety, including fire protection, structural integrity, accessibility, and energy efficiency. Firstly, the IBC serves as a benchmark for jurisdictions seeking to adopt consistent and up-to-date building regulations. Secondly, it promotes uniformity in building practices across different regions, facilitating collaboration and innovation within the construction industry. Thirdly, the IBC is updated regularly to reflect advancements in technology, materials, and construction techniques. Fourthly, the IBC provides a framework for ensuring that buildings are safe, durable, and sustainable. Now let us discuss the National Electrical Code, abbreviated NEC. The NEC focuses specifically on electrical safety and provides standards for electrical installations in buildings and structures. Firstly, the NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Secondly, the NEC aims to minimize the risk of electrical shock, fire, and other hazards associated with electrical systems. Thirdly, the NEC is updated every 3 years to incorporate new technologies, safety practices, and industry trends. Fourthly, the NEC is widely adopted by jurisdictions across the United States to ensure consistent electrical safety standards. Let's elaborate more on fire resistance ratings. Fire resistance ratings are essential for evaluating the ability of building materials and assemblies to withstand fire exposure. Firstly, fire resistance ratings are expressed in terms of time, indicating the duration for which a material or assembly can resist fire penetration and maintain its structural integrity. Secondly, fire resistance ratings are determined through standardized testing methods such as those outlined in ASTM E119. Thirdly, fire resistance ratings are used to specify the minimum fire protection requirements for various building elements, including walls, floors, roofs, and doors. Fourthly, fire resistance ratings help to compartmentalize buildings and prevent the spread of fire, thereby protecting occupants and property. Let us now discuss separation walls in detail. Separation walls play a critical role in preventing the spread of fire and smoke between different areas of a building. Firstly, separation walls are designed to create fire-resistant barriers that limit the spread of fire from one occupancy to another. Secondly, separation walls are commonly used in multi-tenant buildings, such as strip malls and office complexes, to segregate individual units and prevent fire from spreading rapidly. Thirdly, separation walls must meet specific fire resistance rating requirements, as determined by the IBC and other applicable codes. Fourthly, separation walls often incorporate fire-rated doors, windows, and other openings to maintain the integrity of the fire barrier. To ensure that the electrical systems are properly installed with respect to separation walls, it is important to follow specific guidelines. Firstly, electrical wiring and equipment should be installed in accordance with the NEC and other applicable codes to minimize the risk of fire hazards. Secondly, electrical penetrations through separation walls should be properly sealed with fire-resistant materials to maintain the integrity of the fire barrier. Thirdly, electrical panels and other equipment should be located away from separation walls to avoid compromising their fire resistance rating. Fourthly, emergency power systems and fire alarm systems should be designed to function reliably in the event of a fire, ensuring the safety of building occupants. Lastly, regular inspections and maintenance should be conducted to identify and address any potential electrical hazards, ensuring the ongoing safety of the building and its occupants. Now we will look at high-rise buildings, hospitals, and schools, which often require Type I or Type Roman II construction due to the higher risk of fire. These structures typically have a large number of occupants, making it essential to provide maximum fire protection. High-rise buildings pose unique challenges for fire suppression and evacuation, necessitating robust fire-resistant construction. Hospitals house patients with limited mobility, requiring stringent fire safety measures to ensure their safe evacuation in the event of a fire. Schools accommodate large groups of students and staff, making it crucial to provide a safe environment with effective fire protection systems. Now let's look at single-family homes, offices, and retail stores, which are generally considered less risky and may utilize Type Roman III or Type Roman IV construction. These buildings typically have fewer occupants and a lower fire load compared to high-rise buildings or hospitals. Single-family homes are designed with fire safety features such as smoke detectors and fire-resistant materials to protect occupants. Offices and retail stores often have fire sprinkler systems and other fire protection measures to mitigate the risk of fire spread. The specific fire protection requirements for these buildings may vary depending on their size, occupancy, and location. Understanding the distinctions between different building construction types and fire resistance ratings is essential for ensuring building safety and code compliance. By adhering to the guidelines outlined in the IBC and NEC, building professionals can create safer and more resilient structures that protect occupants and property from the devastating effects of fire. Furthermore, ongoing education and training are crucial for staying abreast of the latest developments in fire safety and building technology, enabling building professionals to make informed decisions and implement best practices in their projects. Remember that local codes and regulations may have additional requirements or variations from the model codes, so it is always important to consult with local building officials and qualified professionals to ensure compliance with all applicable regulations. This may include items such as local amendments to the IBC or NEC, additional fire safety requirements specific to the jurisdiction, or any other relevant codes or standards. By working closely with local authorities and experts, building professionals can ensure that their projects meet the highest standards of safety and quality.